Hello everyone, my name is İsmail Tuna Çakmak and today I'm going to present my Phys102 project, which is the response of a series RLC circuit to a rectangular pulse. In this project, I investigated the transient response of a series RLC circuit under different damping conditions. First, to find the theoretical values, we have used Thevenin's theorem, capacitor and inductor theory, Kirchhoff's voltage law, and the Laplace theorem. By using these three theorems, the voltage across the capacitor formula under three different damping conditions were found. In the overdamped case, the voltage across the capacitor formula is found to be this, where the roots are given below. In the critically damped case, the voltage across the capacitor formula is found to be this, where the roots are equal to each other. In the underdamped case, the voltage across the capacitor formula is found to be this, where the roots are complex conjugate roots. The circuit components that are going to be used are shown on the screen. Since these equations are very complex equations, the voltage across the capacitor was found by a Python simulation and plotted. Then the circuits are built in the lab using the same components to experiment and measure using an oscilloscope. For each trial, two time points are measured. For the first two trials, 25 microseconds and 50 microseconds. For the third and fourth trials, 1 microsecond and 2 microseconds. And for the last three trials, the upper and lower peaks were measured. Then the data obtained from the experiment and the simulation were tabled, and an error measurement was conducted. There were small inaccuracies between the experimental and the theoretical values, which was expected due to the tolerance of components and the oscilloscope inaccuracies. However, in the underdamped case, the error rate is much higher than the other cases. The reason behind that is that the resistance in parallel with the voltage generator is much smaller compared to the inner resistance of the voltage generator. This difference leads to a significant amount of current loss, and as the current loss increases, the power loss increases quadratically, which leads to a higher error rate. In conclusion, by conducting this experiment, it is shown that using the theoretical formula and models provided in this project, the behavior of an RLC circuit under three damping conditions could be calculated with small inaccuracies.